Hi, I'm Lauren Helfer, and I'm going to be modeling a numberless word problem question series with you. As I'm modeling today, I'm going to be pretending like I have students with me, thinking of all the kind of wacky, crazy things that a fifth grader might say in this situation, but unfortunately I'm unable to use actual students to do this. We're going to be going through this in 4 parts, one for each of the question series. So let's get started. So I'm using question 3A from the multi-step multiplication problem solving set. So, okay, students, we're going to be looking at this word problem, and it's going to look a little bit different than the word problems that you're used to. One thing you're going to notice about it is it doesn't have any numbers, but don't let that freak you out. We're going to go through it together, and we're going to work on some different strategies for how we could solve this word problem. So first of all, let's read it together. Martina is a salesperson at a shoe store. She will spend part of her workday stocking new shoes. She will spend a longer part of her day with customers than stocking shoes. The rest of her time is spent working at the cash register. So when we read this, we're going to actually pretend like it's a short story. Now, it's a very, very short story, but it does have a beginning and a middle and an end. And we're going to analyze that like we are reading in language arts class. So what can you tell me about what happened at the beginning of the story? You're right. Martina is a salesperson at a shoe store. So what might that look like? Have you ever been to a shoe store? Yeah? Okay, so I'm going to visualize what we're talking about in this word problem here. So we've got Martina, and what's she doing? Yes, she works at a shoe store. So here she is at her work. It's a shoe store. Maybe there's some shoe boxes. We know what a shoe store looks like. Does anyone have any questions about the shoe store? Okay. So at the beginning of the story, we find out that she works at the shoe store. And what do we find out next? Yes, she's going to spend part of her day stocking the shoes. What does it mean to stock shoes? Yes, that's right. It means that she's putting them onto the shelves. So Martina's actually here. She's putting new set pairs of shoes onto the shelves at the shoe store. So that's one of her jobs. So one of Martina's jobs is that she stocks shoes. So everyone agree so far? Yeah? Okay. So what happened next? She spends a longer part of her day with customers. So she's not just stocking shoes, she's doing some other stuff too. Do you agree? So what else is she doing? She's helping the customers. So maybe there's some customers. So she's also helping customers. So what do you think that might look like? Have you ever been a customer at a shoe store? Yeah, they measure your feet with that funny little shoe measuring thing. Some shoe stores, they have to go into the back to find your shoes, don't they? And they bring them out to you. And then at some shoe stores, they're right there on the shelf, and you can just grab them yourself and try them on. Yeah, I don't like the funny socks either. They're kind of gross. But at least that means that people aren't sticking their feet into those shoes, right? You want to wear those. It'll help keep your feet clean and healthy. What else did we find out? She works at the cash register? Okay, so she doesn't just stock shoes and help the customers. She also goes and works at the cash register sometimes. So here's her cash register. I know, I'm not a great artist, but that's okay. Do you understand what it means? Okay. So she works at the cash register. Okay, great. So I think we have a good idea of what Martina is doing at work. Is there anything else that y'all want to add? Oh, right. It does say that she spends longer helping the customers than she does stocking shoes. That's true. So let's use that to help us make some educated guesses. So, how long do y'all think Martina maybe works in the day? 8 hours? I think so that's a reasonable estimate. So maybe she works for 8 hours total. Why is that a reasonable estimate? Yes, a lot of shifts at jobs like that do last for 8 hours. Sometimes more, sometimes less. Yes, it would be different if she worked part-time versus full-time. Oh, your brother actually used to work at a shoe store? Interesting. Did he, how long were his shifts? He worked for 8 hours at a time? Okay. So we think this might be a good estimate for how long Martina is working. So if Martina is working for 8 hours, how many hours do you think she might have spent stocking shoes? So maybe 3 hours? Okay. What about helping customers? Oh, you're right. We know something important about helping the customers. She spends longer doing that than she spent stocking shoes. So how long maybe did she spend helping the customers? No, 2 hours? What about the rest of y'all? Do y'all think that's a reasonable estimate? No, right, because that would be less than her stocking shoes. And it says that she did this for longer. So let's pick a number that's more than what? More than three. So maybe she spent 5 hours? I'm just going to write helping. Is that okay with y'all? Okay. You know what that means? Helping the customers. Now, how long would she have worked at the cash register then? An hour? I'm just going to put it at the register. So would that be 8 hours total? No? What do we need to do? Which estimate do you want to change? Okay. You think maybe she actually worked for 9 hours? Okay, let's update that. I think maybe she worked for 9 hours total. Okay, so would this make sense? Would these be good estimates? Okay. Do we have an understanding of what's going on in the story? How could we represent this with a strip diagram? Do you have any ideas? Okay, so maybe one with 3 spaces? You're saying 4? Oh, for the total? Well, would we normally put the total in a box or would it be the whole thing? The whole thing? So how many do you think now? 3? Okay. So we would maybe have a strip diagram with 3 pieces like this? Okay. Okay, so now we're going to uh, go on to step 2. So this would be either the next process with my small group or maybe on another day when I'm working with my whole class. Okay, so now we're going to read step 2. Martina is a salesperson at a shoe store. She will spend part of her 8-hour workday stocking new shoes. She will spend 1.75 times longer with customers than stocking shoes. The rest of her time is spent working at the cash register. So students, let's see if this still makes sense. So we have Martina, and what did this represent? Her cash register. Okay, so is that still part of the problem? Okay. We have her stocking the shoes. Is that still part of the problem? Yep. Okay. And we have her helping the customers. Is she still doing that in this next step of the problem? Okay. So our picture still works. It still represents our problem. Now let's look at some of our estimates. We decided maybe 9 hours total that she was working. Does that still fit our problem? Oh, we found out some new information. What information did we find out? She only worked for 8 hours. Okay, so since we know she worked for 8 hours total, actually, I'm going to use a different color today to show our changes. We're going to change that. We want that to be an 8 because she worked for 8 hours total. We're certain of that. Is that true? We're certain? Are we inferring, or were we given that information? Yes, we were given the information directly in the problem. We don't have to infer. We also learned another new piece of information. We found out how much longer she spends working with the customers. It didn't tell us she works 1 more hour or 1.75 more hours. It says 1.75 times longer. What does that mean? So did she spend longer working with the customers still? Yes. Okay. Do we know how long she spent? Did she spend 1.75 hours? So should we change this to 1.75? No? Why not? Oh, it doesn't say she spent 1.75 hours. It says she spent 1.75 times longer. What will we need to know to figure out how long she was helping the customers? We would have to know how long she stocked the shoes. Why do we have to know that? Oh, it says in the question that the 1.75 is comparing how long she helped to how long she was stocking shoes. Do we know that yet? No? Okay. So if she did spend 3 hours, this would still have to be bigger though, right? So we're not sure what this number is yet either. We had an estimate of 3. What about how long she worked at the register? Do we know that yet? No? Okay, so let's go ahead and cross out our estimates for a little bit, and we'll come back to those because we don't know any of them yet. We haven't been given that information. We do know for sure that she worked for 8 hours total. Where could I put that on my strip diagram? Ah, you don't like my strip diagram? Is it kind of messy? Let me fix it. Okay, so she did 3 things. And she had a total of, her total will be 8. Do you agree? Okay. So we found out some new information, and then some of the information we can tell it stayed the same. Okay, are y'all ready to start step 3? Okay, now we're going to be starting step 3, which is card C. So let's read this together again. Martina is a salesperson at a shoe store. She will spend 2 hours of her 8-hour workday stocking new shoes. She will spend 1.75 times longer with customers than stocking shoes. The rest of her time is spent working at the cash register. Okay, so is there any new givens that we have? Okay, so let's see. We still have Martina working at the cash register, stocking shoes and helping customers. 8-hour total day. Are there any other numbers that we know? We have a new given. We know that she spent 2 hours stocking shoes. Okay, I'll add it to our strip diagram. 2 hours stocking shoes. Okay, so this part right here, you're saying that you think that this part would be 6? Okay. How did you figure that out? Was that given in the problem? Oh, you made an inference. What did you use to infer that? You knew that if the total was 8 and she spent 2 hours on that, that the rest of the time would be here, and so that would be 6, because 6 plus 2 would give me a total of 8. Okay, nice. Did the rest of y'all agree with that inference? Okay. So are there any other inferences that we can make with our givens? Oh, so we know that this is times 1.75. Times 1.75 of what? Of stocking the shoes. How would I figure that out? I should multiply? Why? Why would I multiply and not divide? Because we know that if it says times, it could be either one. Because multiplication and division are really the same thing. One is forwards, multiplication, and one is the same thing but backwards, division. So how do I know that I'm multiplying? Because if I have a 2 and I want this 2 to get bigger, and I multiply by 1.75, it will get bigger? Okay, so let's try that operation. You do it on y'all's whiteboards, then I'll do it here on mine, and then we'll check each other's work. 0.75 times 2. 2 is 10. Carry the 1. 2 times 7 is 14, plus 1 is 15. Carry the 1. 2 times 1 is 2, plus 1 is 3. 2 decimal digits. What did y'all get? 3.5? You said 3.5. Is 3.5 the same as 3.5? Yes. Okay, so how do we want to write it? Do we want to write it with a half, like a fraction, or do we want to write it with a 0.5 like a decimal? Okay, we're in agreement we want to use decimals because, oh, y'all just like decimals better? You think they're easier? Okay. Let's write our new number, 3.5. So does that fit the problem? Is it, if she spent 3.5 and she spent 2 here, does that fit the problem? Yes. What? How do you know that? Okay, you said that it fits the problem because it's less than 8 when you add those two together. Okay. And you say it fits because, 3.5 is more than 2. So it fits that part of the problem too. Okay, perfect. So we've got 2 and 3.5, and then we've got this missing one right here. What is this missing part? How long she works at the cash register? Could we find that right now? Is it given? Oh, you inferred it. How did you infer it? Oh, you did 6 minus 3.5? And what did you do? You added these together and then subtracted from 8? So y'all two did different things, but y'all got the same amount? How did that work? Oh, one of you used this as the total, and then you used this, but sort of left out the two, but you got the same amount. Okay. So what goes right here? 2.5? So does that fit? Is 2.5 and 3.5 equal to 6? Okay. Is 2 and 3.5 and 2.5 equal to 8? Okay, so it matches our picture. Does it match our story? So helping customers was longer than stocking shoes. And then she spent the rest of her time at the cash register, and y'all are saying that is 2.5. So the customer, she spent 3.5. And here she spent 2. So what about, that's her whole day, right? Okay, so did that come out to, what did that come out to? 8 for the whole thing? Okay, so the total was 8. Does that match our story? Yes, I agree. It does match. Okay, but we don't know what it's going to ask us yet. What kind of questions do you think that this problem might ask us? Okay, so you think that it could possibly ask us how much longer did she work with the cash register than with stocking shoes? Why do you think they might ask us that? Oh, because they told us how much longer she worked helping the customers, so they might ask us the same thing about the cash register. Well, that's a good idea. You think they might ask us if she works full time or not? Would we have the information right now to be able to answer that? Oh, they would have to give us some more information in the question if we were going to if they were going to ask us that, right? They'd have to tell us, well, what is full time and what's part time? Okay, well, I guess they could ask us that. We'll see in a minute. What else could they ask us? You think they might ask us how much longer she worked at the register? No, how long she worked at the register. So just how many hours she was at the register? They could ask us that. Do we have the information? We do. We have it on our strip diagram and in our picture too. Okay. What else could they ask us? You think they're going to ask us which is her favorite? Oh, so you think whatever she did the longest is her favorite. So they might ask us which one did she do for the longest? And then that would be her favorite. Do we have the information that we need to answer that? If they did ask us what did she do the longest? We do. We can tell which one of these numbers is the longest number, is the greatest. Could we tell which one is her favorite though? Yeah, we would need some more information if we wanted to figure out which one was her favorite. I agree. You just wish you knew if it was her favorite. Okay. You don't really think that's what they're going to ask? No, you just think that would be interesting? Okay. So last step. Let's see what they do end up asking us. Martina is a salesperson at a shoe store. Got a shoe store? She will spend 2 hours of her 8-hour workday stocking new shoes. Okay. She will spend 1.75 times longer with customers. Okay. Than stocking the shoes. The rest of her time is spent working at the cash register. How much time will Martina spend working at the cash register? Oh, you had it right. You guessed exactly what they were going to ask us. You wanted to know how long she was going to be at the cash register. So do we know that already, or do we need to do some more inferencing? We do. We know it already. We got it right here. Can y'all help me write an equation that we could use to solve this? Like, you know, sometimes on the questions, they don't want the answer. They want you to tell you like an equation that matches. Okay, so what would we do? What did we do first when we actually started doing some math? Oh, we had to multiply 2 times 1.75. Okay, that was our first step. What can we do with first steps sometimes in math problems? Put parentheses around it. Good job. Okay. What did we have to do next? We added that with the 2. Okay. Oh, I'm out of space. I should have started in a different spot. Here, y'all help me. Help me remember what I was writing. I'm going to do 8 minus 2 times 1.75 plus what? Oh, plus 2. I need to do all of that first, though. What do I need to do? Oh, you want me to? Okay. Put the parentheses around the whole thing. Would we still do the multiplication first then? Yes, because multiplication is groups, so it comes before individual numbers. Okay, and when we did all of that, would we get 2.5? So multiply 2 times 1.75, we get 3.5. Add it with 2, and then subtract it from 8. Yes. So let's put our answer in a complete sentence. How much time will Martina spend working at the cash register? Martina will spend 2.5 hours working at the cash register. Okay, we got it. Good job, guys.